Welcome to video number 5. In this video, we're going to take a look at something called a navigation controller. A navigation controller is a special type of view controller that allows you to manage and display on the screen a hierarchy of views. A good example of where this is implemented is the Settings app that comes on every iPhone. The Settings app has categories. If you select a category, the app drills down into a more specific view. That's done using a navigation controller. So a navigation controller stores a hierarchy of views and automatically handles the process of drilling down into a more specific view controller and going back to a more general view controller. Also, navigation controllers handle all the visual work that coincides with those transitions. So for example, when you tell a navigation controller to drill down into a more specific view controller after the user has selected something in the first view controller, the navigation controller will automatically animate the current view controller sliding to the left off the screen and the new view controller sliding onto the screen. Essentially, a navigation controller stores a stack of view controllers. You can add new view controllers onto the stack and drill down into more specific views, and in the opposite direction, you can pop view controllers off the stack and go back to a previous view. In this video, we're going to make an application that displays a list of people. We're going to create fake people, and we're going to list those people by name in a table view. Then we're going to program our navigation controller and our table view so that when the user selects a person from the original table view, we're going to push a new view controller onto the navigation controller stack, which displays a basic profile for that person. So in our first view, we're going to have a table view that lists all the people but only displays their name. And then selecting on a person is going to forward to a new view controller which displays, let's say, a name, an age, a gender, and a height. To help us accomplish this, we're going to create our own class called the person class, and it's going to have 4 properties to store those 4 pieces of information for each person. And then we're going to hard code in a few instances, let's say 3 of that person class, and then we'll go from there. So, as always, begin by opening Xcode and create a new project. Still, we're going to stick with the single view application template. Click Next, and I'm going to name my app People App. Next one more time and create it on the desktop. Okay, so let's open up main.storyboard and recall that by default, when we choose the single view application template, the first view that's loaded onto the screen when our application launches and the main.storyboard file is loaded is a view controller. By default, Xcode sets up our project so that this view controller is an instance of the view controller class, which again is defined in these .h and .m files, and recall that the view controller is a subclass of the UIViewController class. This way we can customize our view controller any way we like. The first thing we're going to do is we're going to delete the view controller from the main.storyboard, and we're going to delete the viewcontroller.h and .m files. We're going to be making a new class, and we're going to call it PeopleViewController. Okay, so after you've deleted the .h and the .m, go to File, New, File. With Objective-C class selected, click Next. We're going to subclass UIViewController, and we're going to name it PeopleViewController. So this will be the view controller that displays the list of people by name. Hit Create. And now we can add an instance of our PeopleViewController into the main.storyboard file. But first, we have to create a navigation controller first. So we want to design our storyboard file so that when the app's launched, by default, a navigation controller appears on the screen. And inside that navigation controller is going to be the PeopleViewController. So again, the way it works is a navigation controller can store a stack of view controllers, and it will display the current view controller on stack's view inside of its own view. Automatically, navigation controllers will display on top something called a navigation bar. The navigation bar stores things like back buttons, titles, and other controls that might be appropriate for whatever view controller is currently on the screen. So in the object library, look for this icon here, which indicates a navigation controller, and drag onto the scene. So now you can see, represented by this arrow, that automatically the first thing that will appear when the app is launched is this navigation controller. Now, a standard UINavigationController object is completely sufficient for what we're doing, and you'll find it very rare that you'll ever have to customize a navigation controller or make a subclass of it. The standard navigation controller handles everything we need to do completely. Now you can see another view controller was made, and it's called Root View Controller, and its class type is Uitableview Controller. A Tableview Controller is a subclass of view controller, of UI view controller, whose view is just a table view and not a UI view object. So basically, it saves you the steps of manually creating a table view and setting its data source, and then setting an IB outlet back to the table view from your view controller, etc., etc. Personally, I like to stick with view controllers and manually insert a table view, because I found that sometimes you realize later on while developing an app that you need to put other things either above or beneath that table view in your view, and if you're using a table view controller, you have to do that programmatically using the table view data source methods, which can get really messy. So it's much easier just to pop things onto the view using the object library than it is to insert them inside of a table view and make sure they're the right height and they're placed at the right spot and whether or not you want them to scroll off the screen, etc., etc. So I'm going to delete this table view controller and make a fresh view controller. So in the object library, look for the view controller icon and drag onto the scene. So now we have to give our navigation something called a root view controller. That'll be the view controller that it displays first, the root view. As of right now, our navigation controller doesn't have any view controllers on its stack, so it has nothing to display. We can fix this very easily using our storyboard file by right-clicking and dragging from the navigation controller to our newly created view controller and under Relationship Segue, choosing Root View. So now there's a relationship between the navigation controller and this view controller, and that relationship is that this view controller is the navigation controller's root view. So when the app's launched and the navigation controller is displayed on screen, it'll display this view controller's view inside of itself beneath the navigation bar on top. The next step is, as of right now, this view controller is just a standard UI view controller object. We need to change that so that it's an instance of the people view controller so that we can modify it programmatically. So select a view controller from the scenes menu, and in the utilities panel, select the identity inspector and change the class type to people view controller. Now, let's add a table view onto our people view controller's view. So, in the object library, scroll down until you find the table view indicator icon and drag from the object library onto the view. Now you can see that the table view automatically sizes to fit the entire view's height and width, but fortunately when you display a table view inside of a navigation controller, it'll automatically resize the table view to fit inside the navigation controller's view beneath the navigation bar. So first, let's give our table view some dummy data to display just so we can see how it's laid out inside of the navigation controller. So right-click and drag from the table view to the people view controller in the scenes menu and connect the data source outlet. Again, this way the table view knows what object to message to get its data from. And now let's implement those Uitableview data source methods. First, we have number of sections in table view. We're going to return the constant 1. We only need one section. Next, table view, number of rows in section. Let's just return 3. And then finally, our self for row at index path method. Now I'm going to speed through the implementation of the self for row at index path method. I'm going to assume that you understand how the implementation works. If your mind needs to be refreshed, pause here and go back to the previous video, and then once you've rewatched that, come back here. So, first, we check to see if our table view has any reusable cells with the identifier main cell. If not, let's create one. and we set some text for the cell, and then return it. Let's launch our application and see what we've got so far. Okay, so at the top here is the navigation bar, and beneath the navigation bar, the navigation controller will take whatever view it's supposed to currently be displaying, or whatever view is on the top of the stack, steal its view from the view controller, and display it beneath its navigation bar. Now, all view controllers have a title property, and when you display a view controller's view inside of a navigation controller, it'll check to see if that view controller's title property has been set, and if it has, it'll display that title representing that view controller right in the middle of the navigation bar. So, let's give our people view controller a title, and then relaunch the application. So in the viewDidLoad method, we can simply add self.title equals people. So now we've set the title property for our people view controller to the string people, and when the navigation controller displays our people view controller inside of itself, it's going to grab that title property's value and display the string in the center of the navigation bar. So let's launch the application again, and you can see the title people is displayed right in the center of the navigation bar. Also, as we mentioned earlier, you can see that the table view has automatically been resized to fit inside of the navigation controller beneath the navigation bar. Okay, now let's define our person class. Again, we're going to create one instance per person of our person class, and we're going to use that person class to store a name, a gender, an age, and a height for each person. So again, file new, file, Objective-C class again, next, but this time we're going to subclass NSObject. Again, remember that NSObject is the root of all objects for Objective-C, and it's fully designed and implemented to provide genuine, complete object support on top of the C language with things like memory allocation and initialization. And so since our person class is going to be an object and its only specification is that it's going to store some data, we're going to subclass NSObject and then just add some properties for each piece of data. So we're going to name this class person, click next, create it, and now we have our person.h and .m files. So all we have to do to fully implement our person class is define those four properties. Then we can access those properties from the view controller later on, set them, and then retrieve them when we need to display each person in the table view. So add four properties. First one will be name, the second will be gender, the third will be age, and the fourth will be height in inches. Now, we discussed properties in previous videos, and we said that a property is basically a way for making an instance variable of a class public. By public, we mean accessible to outside objects via getter and setter methods. So the values of these properties are going to be stored in instance variables of the person class, but as of one of the more recent updates to the SDK, Apple has made it so that you can define a property without a matching instance variable, and the compiler will automatically create an instance variable for you for storing that property's value. The copy attribute tells the compiler and the runtime environment that when we set a value for this name property, the person class is going to make a duplicate of the object we pass in and then store a reference to that, as opposed to storing a reference to the original value we give it. This way, it doesn't have to worry about if the original object is destroyed and erased from memory. Now, in person.m, we have to do something called synthesizing our four properties. So at this point, we've declared our four properties, but now we have to synthesize each property, and the compiler will replace each of those lines with the actual getter and setter methods for that property. So first, we put @synthesizeName. Here, the compiler will replace this line of code and insert instead one getter method for retrieving the value of the name property and one setter method for changing the value of the name property. We can do this for all four properties. Okay, so now our person class is fully implemented and prepared to store a name, a gender, an age, and a height for each person. And so now we can create instances of this person class, and in each instance store data for whatever particular person that object is representing. Again, we're going to hard code this in our viewDidLoad method. So go to peopleviewcontroller.m and first import person.h. Now we can use the person class. If you don't import the header file for a class and you try to use it, the compiler is going to throw errors because it's not going to know what that class is. Next, we need to give our PeopleViewController an array for storing all of the people we create. So in PeopleViewController.h, add an instance variable of type NSArray, and we'll call it people. Now we can create 3 person objects. So in the viewDidLoad method, begin by creating person 1 like this. So here, we've allocated memory for and initialized a person object, so this means we do have a usable person object. But now we have to set the values for those 4 properties for this person1 object. So we can do that like this. Person1.name equals Mary Cunningham. Next, we set the gender, F for female. Next, we can set the age, we'll put 29. And finally, we can set the height in inches, and we'll say 60. Now let's create person 2. And finally, person 3. Now that we have 3 person objects with all of their properties set to whatever we wanted to set them to, let's add all 3 of those person objects to our people array. So first we have to initialize an NSArray object and have the people pointer point to that NSArray object. And with this initialization method, we're going to insert all 3 person objects into this array. So we can do that like this. And now we have a people array which stores all 3 person objects. So now we can modify our data source methods and display the name of each individual person. So first, instead of returning a constant for the number of rows in our table view, we're going to return the count of the amount of objects in the people array. So people count. In the self_row_index_path method, we can pull the person that corresponds to this particular row by using the index of the row and using that to retrieve whatever person object is at that same index in the people array. So person, we'll call the pointer this person, equals, we have to cast person class onto whatever is returned from the people array, and then people object at index path.row. And finally, we can set the text for this cell to this person.name. Save and run your application again. Okay, perfect. So we have still 3 rows in our table view, and each row displays the name of whatever person corresponds with that row in the people array. The 0th object in the people array is the person object that represents Mary. The 1th object that corresponds with row 1 is a person object that represents me. And finally, the 2th row corresponds with the person object that stores a profile for a person named Joseph Thomas Frizzalone. So the next step is to make it so that choosing one of these rows drills down into a more specific view controller which displays all the information on that particular person. So quit the application, and we're going to make a new view controller. Go to File, New, File, again Objective-C class, This time it's going to be a subclass of UIViewController, and we'll call it PersonViewController. Down here we have an option that says with XIB for user interface. Here, for the first time, we're going to take a look at how we can use more than one interface file. So this far we've only used main.storyboard for graphically creating UIs for our apps. Now we're going to create another interface file, and we're going to use Xcode's built-in GUI and design an interface for our PersonViewController. And then when we make an instance of our PersonViewController, after a particular person is selected in the table view, we're going to load that PersonViewController instance alongside whatever's inside of our XIB file, and the view that we have designed inside of that zip file will be set as the view for the PersonViewController instance that we create. If at this point you suddenly become lost, don't worry, it'll make sense when you see it in action. So check off with zib for user interface, click next, and create it. And now you can see we have three new files, a .h and a .m, for defining and implementing the PersonViewController class, but we have a third file, PersonViewController.xib, and here we have a new interface file for designing our PersonViewController's interface. So you can see if we click on Files Owner and we open up the Identity Inspector, you can see that the class type is PersonViewController. So what that means is Files Owner represents a PersonViewController object. And it's called Files Owner because when we create an instance of our PersonViewController, which we'll do programmatically, the PersonViewController will consume this zip file, and this Files Owner object will be replaced with a reference to that newly created PersonViewController object. In other words, anything we do in this zip file to the Files Owner will be done to the PersonViewController object we create programmatically. And you can see with Files Owner selected, if we open up the Connections Inspector, the view outlet is set to this view created graphically using Xcode's GUI. So, as we said in the beginning of the video, when a user selects a particular person from our table view, our people table view, we're going to drill down into a more specific view controller and display everything we have on that particular person. So we're going to need 4 labels. One for name, one for gender, one for age, and one for height. Okay. Now we have to create an IB outlet for each of these 4 labels. So in PersonViewController.h, add these 4 outlets. Now save and go back to PersonViewController.zib and right-click and drag from Files Owner to each of the matching labels. So first we have to go to the .h, and we need to make a way so that when a user selects a person from our table view, we can pass on to the PersonViewController the person object represented by that row. So if the first row is selected, Mary Cunningham, we need to give this PersonViewController the person1 object so it can take all of the data contained for that particular person and display it in the 4 labels. We can do this, as you probably already guessed, with a property. So first, we need to make a call to the @class keyword. This simply tells the compiler that we're about to reference a class that it doesn't know of yet because we haven't imported the header file, but not to worry because we will import it in the .m file. So add a property. We'll call it just person, and then synthesize that property in the .m file. And at the top, import the header file for the person class. Now we can reference this person property and set the values for the 4 labels appropriately. So First, name label, text. We're going to use formatted strings. Name, colon, and then %@ followed by person.name. Next, the gender label. Next, the age label. And finally, the height label. Okay, so our person view controller class is fully implemented and ready to be used. So now we can go back to the people view controller, import person view controller.h, and now we have to respond to a user selecting a row in our table view. For this, we can use the Uitableview Delegate outlet. A table view's delegate is an object that it will send messages to alert it that something has happened in the table view. So when a user selects a row, the table view will check to see if it has a delegate, and if it does, it's going to message the delegate and say, look, a user just tapped on this row, and it'll pass in an index path to represent whatever row was tapped on, and then we can respond however we need to. So go back to main storyboard and right click and drag from the table view to the person view controller option in the scenes menu and connect the delegate outlet. Save, and now we can use a method called didSelectRow@IndexPath, and it looks like this. So the table view will message our people view controller in this form, and it'll pass in an index path for the path of the row that was selected by the user. Here, we're going to make an instance of our person view controller, give it the person object that corresponds with the row that was tapped, and then push it onto the navigation controller stack so that the navigation controller can display its view inside of itself on the screen. So first, person view controller, I'm going to call it pview, equals person view controller, alloc, and now we're going to use a method called initWithNib bundle. So we pass in a string that represents the file name of the zip file we're going to load it with, and that's person view controller. We leave out the extension because the method assumes that it ends in .xib. And then we can pass in nil for the bundle. Don't worry about what a bundle is. That's very much outside the scope of this video. Just know that any files listed here are in something called the main bundle, and you can pass in nil, and then this method will assume that this file is somewhere in here, which represents basically your project folder. Now, let's grab that person object, give that person object to our newly created person view controller, and now we can push this new person view controller object onto the navigation controller stack, and the navigation controller will display it. So, to reference back to the navigation controller that this view is sitting inside of, remember that we're doing this inside of peopleviewcontroller.m, and an instance of peopleviewcontroller is sitting inside of a navigation controller when our app launches. So we can reference back to the navigation controller that this view is currently inside of using the navigation controller property. So when you add a view controller to a navigation controller's view controller stack, the navigation controller will set that view controller's navigation controller property to itself so that that view controller can reference back to whatever navigation controller it's sitting inside of. In other words, we can reference the navigation controller like this, self.navigationController. And now we use a method, pushViewController, pview, animated yes. We say yes for animated so that the navigation controller will visually animate the pushing of that new view controller by sliding off the old view and sliding in the new one. And now we can run the application. So you can see if we select a row, our person view controller is instantiated and pushed onto the navigation controller stack, you can see that automatically the navigation controller creates a back button to go back to the previous view controller, and it sets the title of that back button to the title of the previous view controller. So the title here is people, so when we drill down into a new view, the back button says people. And the last thing we want to do is indicate to the user that this row can be tapped and bring you to a new view. We're going to change something called a Uitableview cells accessory indicator property. So quit the application, back in the cell for row at index path method, give the cell an accessory type, and we can pass in one of a few different predefined constants that represent different visuals for indicating to the user what action might happen should they select a row. And then what we want to use is Uitableview cell accessory disclosure indicator. Save, run your app again, and you can see that the cell automatically adds a nice little arrow to indicate to the user that if they select this row, they'll be forwarded to a new, more specific view. And if you like, you can also add a title for the person view controller, the same way we did with the people view controller in the viewDidLoad method. And we've successfully implemented a functioning navigation controller. Now you can push onto a navigation controller stack as many view controllers as you like. So after selecting a person, you could have a new table view which lists some other pieces of data and then select something from that table view and drill down to another view and so on and so forth. And now that you know how a navigation controller works and how absolutely simple it is to implement, you can play around with some of the apps you have on your iPhone and see where developers have implemented a navigation controller, and you can look at that and realize that it was actually very easy to accomplish that. As we said earlier, the navigation controller takes care of almost all of the work, especially the visual stuff. And you can customize the way that your navigation controller works and the stuff that it displays in the navigation bar. For example, you can add another button to the right here using a view controller's navigation item, and you can even mess with the color scheme of the navigation bar if you'd like to. Personally, I like the color scheme that iOS 7 comes with, so I would leave it like this, but if your app follows a totally different, much more specific color scheme, you can colorize your navigation controller however you like. Anyway, that concludes video number 5. Head on over to video number 6 to see how we can track a user's finger as it makes contact with their iPhone or iPad screen.